So good to see faces. It's so nice to be here. Thank you very much for inviting me. I'm actually nervous. This is the first talk, the first conference in person I've been in like 2 years or something like that. I've been talking to this camera here, and yeah, it's not as fun. Cool. So we're gonna be talking about modern Python through FastAPI and friends. So let's start with that. First, who am I? I'm Sebastián Ramírez. I live in Berlin, Germany. You can find me on the GitHub, Twitter, all the stuff. I'm actually from Colombia, South America. That's why the accent. I currently work as a staff software engineer at Forethought, and I'm also doing some external consultancy for other teams. I created FastAPI, Typer, and recently I released SQL model like 2 weeks ago or so. So we're going to be talking about modern Python. Can you actually all see the slides, or should I move a bit? Okay, cool. We're going to be talking about modern Python, and when I say modern Python, I mean the Python versions that are currently supported, the ones that have not reached the end of life. So it's 3.6 and above. We're going to talk a little bit about f-strings, about type annotations, then a lot about type annotations, a bit about async and await, and some about performance, and then community. We're going to see examples with FastAPI, Typer, SQL model, and all the friends and all the tools that are working behind the scenes. So why am I here? For those that didn't raise their hand when ADs asked if you wanted to hear my talk, FastAPI is a framework for building web APIs with Python based on type annotations, and it has 35,000 GitHub stars. It's been growing about 1,000 stars per month. It's currently used at Uber, Microsoft, Netflix, and a bunch of other places. The performance is in the top rank of what you can get for Python. And it's currently the third most used web framework for Python, right below Flask and Django, and by the official Python developer survey. And by the Stack Overflow developer survey is the third most loved web framework, mixing with front end and stuff. So it's right above React, which is quite cool. Yeah, that's why I'm here. Now let's actually start with modern Python. So we're going to talk a little bit about f-strings. So let's start with this. We have some data here. That is some recipes. Each recipe has just some ID, some ingredients, and then we have a default price. Now we have a function here, and this function takes a name, and it's going to give us some output about the recipe. It's going to tell us like, hey, this is the recipe, these are the ingredients, and this is the default price. It's quite simple. Now if we run it, we of course get the expected result. We can get the recipe for a crunchy-frog, and we get the recipe for crunchy-frog. We get the ingredients, the total, all the stuff. And if we say that we want a quantity of 2, then we get the total is 2. Nice. But if we see here, we have a bunch of repetition in this line. We are using this is a standard string with formatting. So we are using the method.format, and then we pass a keyword argument name with the value that we want to put. And if you see, we are repeating name 3 times here. And we can replace that with just the f string here, where we just put the name inside of these curly braces and the f at the beginning of the string. And this has better performance, and of course, it's simpler and easier to use, and the editor can help us a lot. Very simple, but of course, it works as expected. There's nothing there new. And we can avoid a bunch of repetition, and we can keep stuff simple. That's just to start. So a little bit about f-strings. Now let's talk about type annotations, and we're going to spend here a bit of time. So why would we want to have type annotations? Let's say that we don't like to get the message saying like, hey, this is the recipe for the crunchy-frog, because it looks ugly. We want to replace that middle dash. Can you actually see all? Should I move a bit? I will assume yes. Cool. We want to replace this string that we are returning there. We want to replace the dash for a space, and we want to make it in capitals. But if we trigger autocomplete in this function, we won't get anything, because the editor doesn't know that this variable, this parameter, is a string. So yeah, but we have been working without type annotations, without autocompletion of our life, so it's fine. We can deal with that. But if we change just in this name, if we tell the function, if we tell the editor, hey, this parameter of the function, this is a string, and this is how we say it. We just say colons, and then string, this is a string, suddenly we get autocompletion. The editor will be able to tell us, hey, because this is a string, you have these autocompletion methods and this is stuff that you can do with strings. And because the editor knows that the result of dot replace, so now we're replacing the dash for a space, the editor knows that the result of this is a string 2, we keep getting autocompletion. So these type annotations are what provides autocompletion in the editors. So now we have autocompletion for all this stuff. And this is like the final line. This is what we end up having. And if we call it, of course, it just works the same. It's just that it makes our lives simpler. Now, let's say that we actually don't want to always give a quantity of 1. Maybe some people just want the recipe and they don't really want to order one. It's a simple refactor. We just change the default from 1 to none. Cool. That sounds fine. And now if we run it after we run this, we get an error telling us, hey, default price is an integer and quantity is none, and you cannot multiply an integer with none. So we're getting an error after the fact. But then if we change this annotation here and we tell the editor, hey, this quantity by default is none, but the type of this is an integer. So the editor will know that this is an actual integer and that this should be an integer. That this should be an integer or that it could be none. The editor will know what is it that we're dealing with. And now suddenly we have this inline error in the editor. So we can detect bugs before having to run the code. Right in the editor, we will get those red lines telling us what is wrong. In this case, default price is an integer and quantity is none, so this is not a valid operation in the case that quantity is none. So the type hints, these type annotations or type hints are protecting us from a bunch of bugs. That's the benefit we get from that. Now, how do we fix that? Instead of just returning this whole dictionary, we can just put the dictionary in a part, in this result here, and then we can check if quantity is actually not none. And if it's not none, then we can use it, because it means that it is an integer. So it can be none or an integer. And if it's not none, then we just use it. Now, if we see this is actually still showing a little error saying that, hey, you are putting here, this will be an integer, but this dictionary will contain other stuff. So why is that? This is because now that we are adding some annotations, the editor is actually trying to be super smart and guessing what is the type of this dictionary. So it's guessing that this is a dictionary that has as keys strings and the values strings or lists of strings, or actually sequences of strings. But then we can just tell the editor, hey, don't try to guess too hard. This is just a dictionary of anything. So don't guess what are the values of the keys. And now the editor will know, okay, cool, this is a dictionary that can take anything. And now we don't have the error, the little error here. And now our code is working, and the editor is helping us detect all those bugs. And now notice this. We annotated this as quantities an integer that by default is none. So the editor knows that this is an integer or that it could be none. But then when we check here, inside of this if block that is checking if this variable is none, the editor knows that inside of this block, this variable or this parameter is actually an integer. So it won't complain that, hey, this could be none, because we're inside of a block checking that. Now we can be a bit more thorough and a bit more structured and tell it explicitly, hey, this thing is actually an integer that is optional, so it could be none. This is the standard way in Python to tell it that this quantity is an integer or none. This typing module is part of the standard library, so we can just use it directly. Now in Python 3.10, this is going to be even better, even simpler. But yeah, for now, let's keep it like that. So with type hints, we have more robust code. We have a bunch of error detections. We have inline autocompletion, inline errors. And without type hints, we have to deal with the stuff that we have been dealing with. Now, some of the people behind these type annotations, these guys are the maintainers of MyPy, which is the tool that is used to check for these type annotations. And actually, this guy is the one that started it all. And MyPy is the thing that these type annotations are based on. So thanks to the work of just a bunch of people, we have a bunch of benefits now in Python. Now let's talk about more Python with type annotations using FastAPI. So FastAPI is all based on type annotations. So let's actually build a web API from the same function that we had before. So we just import FastAPI. We create an app, which is an instance of this class FastAPI. And then we use a decorator with app.get. This get means that this will handle HTTP GET requests, so GET operations or GET methods. And this is going to go to the path slash recipes slash, and then this name here, this is going to be a path parameter. And we are using the same format that we use for F strings, so this should be relatively familiar. But this is not an F string. We don't have an F here, and we don't have a variable name on top, but it still is the same format. Now, what FastAPI is going to do, is that it's going to take this parameter from the path, and it's going to put it in this parameter in the function. And we're going to have the path parameter inside of the function, and we're going to be able to use it inside. And then this quantity is going to take it and put it and read it from the query parameters of the request. So the more FastAPI code we write, the less API code we write, because we can just focus on the actual business logic, on the actual code that is important for our app. And of course, because this is all based on type annotations with autocompletion everywhere, and autocompletion, which is nice. And we get all the errors, inline errors, from the detection of these types. And by using FastAPI, we can go to /docs, and we get this automatic interactive documentation interface for the API that is generated automatically from the type annotations that we used. And we can actually use it interactively and send the request, and then we will get a response that this is talking directly to the actual API that is running. So we can interact with our API and debug and stuff and check it live. So we write some basic code, and good guy FastAPI makes a docs user interface for us. Now, this is not only doing documentation of the data from the type annotations. It's also doing data validation, because we declared that the quantity should be an integer. If we try to pass it 9, which is a string, then the user interface is going to tell us, hey, this is not valid, and it's not even going to allow us to send that value. But if we tried really hard, and we just send the request through the command line or through code, FastAPI will still validate the request and will give us a nice error. It won't only tell us, hey, this request is invalid. It will tell us exactly where is the point where there's invalid data. So we can see that in the query parameter, the quantity parameter, the value is not a valid integer, which is what we declared. So this can save us a lot of time debugging and save the clients of this API a lot of time debugging. So without valid data, FastAPI will protect our code from running with invalid data. And with valid data, we will just get all the code that we wrote just as we wrote it. Now we also get data conversion based on these type annotations. So we declared that the quantity was an integer, and it's shown here in the interface as an integer. But we are sending it in a URL, and a URL is by default a string. It's just a long string. But still, FastAPI is going to read it from there, and because we wrote the annotation as an integer, FastAPI is going to convert that value to an integer, and we're going to get an integer back. So in the response, this is a JSON integer, this is not a string, so we are actually getting an integer as we declare it. And this is all based on the standard type hints. We don't have to learn a new type of interface, new classes, new types. We don't have to do anything else to get all that based on type hints. So FastAPI is based on standards, OpenAPI, which internally uses JSON schema and also uses OAuth 2. You don't have to know all that, but because of this, we can get this automatic API docs. This is actually powered by a tool called Swagger UI, and this tool is based on OpenAPI. And because FastAPI is based on these standards, we get all that. And because we are using standard type annotations, we get all the autocompletion and inline errors, but we also get automatic data conversion and data validation. And data documentation, of course. Cool. Now let's change the example. Now let's see how we can use these type annotations with Typer. So now let's say that we are building a command line application, not a web API, a command line application. So instead of importing FastAPI, now we import Typer. We create an app with Typer. We decorate this function with app.command. So we are telling this Typer app, hey, this is, oops. OK, yeah. This is the command that I want to run. And now, because we don't want to just return something because this is not a request, we want to print something on the screen, we are saying, hey, Typer, echo this result. So we just add a little bit of Typer salt. And now we get an automatic command line interface application from that function using type annotations. So for example, if we just call it like that, it will say, hey, you have a missing argument name, because this is required. And then if we pass the name, then we get the result as we expected. And we also get automatic CLI options, like the quantity that now is 2. And we also get data validation. If we say, hey, the quantity is 9, we will get an error telling us, hey, you passed an invalid parameter for this CLI option, so this has to be an integer. And when you build a package with Typer, and your users install it, and they install completion, because it comes with shell completion by default, they will have a shell or tab completion in their terminals. So they can write, for example, --q, and then hit tab, and it will autocomplete the rest of the options or of the subcommands that it will have. And this works in fish, shell, C shell, bash, PowerShell, like everywhere, even in Windows PowerShell. So you're building CLI apps with Typer with just using the same type annotations. Now, we can extend this a bit with a little friend. We can use Rich, which is another modern library we can use. And with Rich, I won't show you all the details, but we can import some tools here. And then we can use this to print a table that is going to show us the stuff more neatly. So if we run that, then now we get this table with all the stuff that we wanted. But now it's shown much more pretty. So very easily with these modern libraries, we can have a command line application quite quickly. And if you combine Typer with Rich, this is a very good combination for building command line applications. Now, some of the people behind, because I want to show you all the people behind these tools. Typer is actually based on Click. Click is the thing that does all the actual work behind the scenes. And Click is maintained by David Lord. And Rich, which is the other tool to show pretty information on the terminal, is built by Will. Will, just like 2 days ago, decided to go full-time on open source, so we're also going to see a bunch of improvements and features from his work. But what I want to show you is that this is just like normal people building these tools behind the scenes. Now, let's say type annotations with FastAPI, and now we're going to use Pydantic. So FastAPI is built on top of Pydantic, another tool called Starlet that I'll show you in a bit. But because it uses Pydantic, we can use Pydantic directly to declare the shapes of the data that we want to receive in JSON. So, for example, let's say that now we want to receive some food, some recipes or some recipes for food. And we just import from Pydantic, we import this base model, and we use it like this. We create a class, and then we declare what are the attributes of this class and the types using the same standard type annotations. So we're saying that this name is a string and the ingredients is a list of strings. And this list of strings, this is the standard way to declare in Python that something is a list of strings. This list also comes from typing. And now we just use this class food that we created here. We use it as a type annotation in the function here as a parameter. So this is, again, the standard way to declare that something, that this parameter food, should be an instance of this class food. And this is what FastAPI is going to give us. So we will have this parameter food that will have a name and will have some ingredients, so we can use it internally. And of course, FastAPI is going to read that information that we declared with standard type annotations and generate the documentation for that automatically. And we can, of course, execute it and interact with the API directly and get the results back live with the API running just from the browser. Now, what happens if, what happens if we send invalid data in this request? So we say that we wanted to have a name, which is a string, and we wanted to have ingredients, which is a list of strings. That's what we declared. So this second item, this is actually a JSON object. This is not a string. And if we send that, we will get, again, a nice error telling us where is the validation error. So this is telling us, hey, in the body, in the item ingredients, in the index 1, a string type was expected, and we actually sent a JSON. So this is giving us validation errors from the data types that we declared from the same type annotations. Now, what if we want to nest data? Let's say that we want to have not just one single food item, but a list of food items. We can declare now that this is an orders this orders parameter is going to be a list of food instances. Again, this is the standard way to declare that in Python. And FastAPI will make sure that this is what we receive. And because this is a list, we can iterate on this list, and we will actually receive an instance of this food class in each one of these items. So we will be able to just use them internally. So if we want to have JSON inside JSON, we can just do that with the same standard type annotations. And because this is all based on the same standard type annotations, we get autocompletion even for deeply nested data structures. So for example, check this out. This is a double nested for loop. And we are iterating for each one of the ingredients in each one of the food items. And because we are using these standard type annotations, we can get autocompletion for each one of them. So we get autocompletion everywhere again. And of course, we get inline errors even for these deeply nested data structures. And these deeply nested data structures can be as complex as you want to declare them, and they will just work. And we will get validation, autocompletion, and all that stuff, even for those data structures. Also notice that these data structures, we are building them with the shape that we need. It's not something that is provided by FastAPI that it's telling you, hey, this is the shape that you have to send. It's something that we declared, how we want to receive the data. And we get all that stuff from that. Some of the people behind the scenes from this. So FastAPI is built on top of Pydantic and Starlet. Starlet does all the web stuff. Pydantic does all the data validation and serialization and all that stuff. Samuel Colvin is the creator of Pydantic. Tom Christie is the creator of Starlet and a bunch of other projects. And David Montaghi is a notorious contributor to Pydantic and FastAPI. But again, this is just normal people doing stuff to help others. Now, we can use the same type annotations to combine FastAPI with SQL model to interact with databases and build a web API that communicates with a database. So SQL model is based on SQL Alchemy and Pydantic. So we get this, we can declare this, we can declare this model. This is equivalent to a Pydantic model and equivalent to a SQL Alchemy model at the same time. We are saying, hey, this is a primary key, the name should be a string, serial name should be a string too, and age is an optional integer that by default is none. Then we just create an engine. In this case, this is a SQLite engine. And then we can use that in the FastAPI application. So in this case, at startup, we're just creating the whole database. And then we can use that same hero class that we created, that is a Pydantic model and a SQL Alchemy model, by being a SQL model. And then we can use that same hero because that is also a SQL Alchemy model. We can use that directly with the database. We can save it, we can commit to the database, we can refresh the data, and when we can return it. And then we can also use the same response model. If you have ever used FastAPI, then this response model is used to declare what is the data shape that we are going to return. So we also get it in the documentation. And it's also used for doing data filtering and data validation in the output. And if we do that, we can also create another path operation, another endpoint to get all the heroes. So we just use the same session, we execute the session, we select the heroes, and we just return them directly. And again, we use the same type annotations. In this case, we use in this parameter to tell it that, hey, we are going to return a list of heroes. And now FastAPI with that is going to generate the same documentation that we have been seeing, using the same data types that we declared. So we can keep the same database and data models without duplicating all the information. So SQL model, the people behind this SQL model is based on top of Pydantic and on top of SQL Alchemy. And these tools were created by Samuel Colvin and Mike Bayer. So what is the deal with async and await, and what is the stuff with the performance and concurrency and all the stuff? So here's the thing. Python as a programming language is very fast when you compare it with, don't look at me like that, when you compare it with the network. If you are waiting in the network for clients to send data and to return data back, then that is much slower than the execution that you can get in Python. If you're building a kernel for an operating system, then you probably will use another language. But if you're building a web application or most of the other things that you could build, Python is probably a very good idea to use. So this is the problem. If Python is fast, sort of, and the network is very slow, how can we improve that so that we can have better performance? So the first idea is that we can just use a bunch of clients in parallel, all of them talking to the same application in Python. So this sounds great, but then in reality, by default, it will be more like one of these lines. So each one of these people is waiting for the one in front to pay before they can actually go to the cashier. So the Python application will be sort of the cashier. We're just waiting for each one of them. So it actually looks more like this. We are waiting for the network, which is slow, and then each one of these clients has to wait for that slow network before they can even start sending information or requesting data. And then our API application is just waiting there for the network for a long time, not using the CPU. So here's the idea. What if we had something like a waiter that can go to each one of the clients and then ask each one of them what they want, and then just send the information back concurrently. So this is what we get with async and await. So your application will be kind of a kitchen preparing meals, and then async and await will be sort of like a waiter that is going to each one of the tables and asking them, what do you want to order? So this guy wants a salmon, they here want a beef, and this, for example, this one here could be my sister that is taking a long time to decide if she wants beef or chicken, and is gonna wait there forever. So now the waiter can say like, you know, keep the menu, I'm gonna go to the next table and go to the next one and ask them what do they want. Meanwhile, this waiter is taking each one of these orders and sending them to the application, saying, hey, this is what I need you to cook. So the application can be using the CPU all the time, always cooking meals, sort of, and we don't have to be waiting for my sister to decide if she wants beef or chicken. And this is how this looks like in code. So we just use async and await. And we start with, so FastAPI is actually, behind the scenes is an async framework, so it supports both normal functions and async functions. We start with an async function, then by adding an async function, we can use this keyword await, and then this keyword await, now we are using HTTPX here. We are using this async with to create an async client with HTTPX. And now this client.get method, this get here, it was created also using async def. And when it's created with async def, we have to use it with await. And this await, this is the point where we are telling the waiter, hey, this might take a while because this thing might be my sister undecided if she wants beef or chicken. So you might want to check the next table what they want to order meanwhile. And by doing this, we can serve a bunch of clients at the same time. So that's all the deal. And of course, the user interface and the API all works the same. We can get the results back, and all the stuff works as normally. Now, there are some caveats with async and await. We have to make sure that all the libraries that we are using are compatible with async and await, because if we are using a library that is, for example, going to cook the meals without using await, it will be like having the waiter take the order and then have the waiter go to the kitchen to prepare the order before asking the other tables. And we don't want that to happen, because that will be even worse. So we have to make sure that these libraries are compatible. But then we can actually, for example, with FastAPI and with HTTPX, they are both compatible with async or non-async. So we can just start with normal def functions, and then we can optimize those path operations or those endpoints that really need the extra performance in terms of concurrency. In terms of concurrency or throughput, which means how many clients we can serve at the same time. So this is what we are talking about. So we can just get both normal def and async def in these cases. Some of the people behind the scenes in this async and await stuff. So Tom Christie, again, he's the creator of Starlet, which is what FastAPI is based on, which is an async framework. Also HTTPX, which is the tool I just showed you to communicate with remote servers. So HTTPX is pretty much like the modern requests. Florimon Manka is also co-maintainer of HTTPX, and all this stuff with the web framework, with FastAPI and Starlet, they are all based on this standard ASCII, the ASCII specification. This actually came from the people at Django, and this was created by Andrew Godwin. So cool. Now, with FastAPI, in terms of concurrency and throughput, like the amount of clients and the amount of requests that we can get, has pretty good performance, in the ballpark of the best that you can get with Python. So this is a benchmark run by a third party, And the blue lines are Python, the green lines are Golang. There's a bunch of other languages and frameworks, but this is a nice, nice comparison, because Golang is compiled. It's a compiled language. It has to be faster than Python. But still, by using these tricks with async and await and all that stuff, we can get a better performance than with some of the frameworks with Go. So that's quite nice. Which one of these is the fastest is not necessarily that relevant because this has some noise. For example, FastAPI is based on Starlet, and Starlet, FastAPI, and all this stuff is run by Uvicorn. Uvicorn is the actual server that is running. If you have ever used Unicorn, this is the equivalent. So this actually should be on top of everything. But the important thing is that you get on the ballpark of the best performance that you can get. And as you can see, this has over 15,000 something requests per second. So it's over 9,000 requests, which is quite nice. Now, why is it that we get good performance with FastAPI? FastAPI doesn't really do anything fancy, but it uses very powerful tools underneath. So Starlet is a web toolkit or micro framework that does all the web parts, and PyDantic does all the data validation and serialization parts. Starlet implements this ASCII specification, and Uvicorn is the server that runs the application. So when you run something in the command line, it will be Uvicorn. And this Uvicorn will use the application that you built with FastAPI or Starlet or anything else. And Uvicorn uses UVLoop, which is a high-performance async I/O drop-in replacement. So you don't really have to do anything to use UVLoop, but it will be used underneath, and you will get like all that extra performance. And UVLoop is built with Cython, which is a sort of compiled Python. And PyDantic is also built with Cython. So we get all this extra performance because all these nice people are building this stuff with high performance using Cython and using all these nice tricks. So that's why we get nice performance with FastAPI, just because the tools underneath are very powerful. Now, some of the people behind the scenes of these things, again, Tom Christie, the creator of Starlet and Uvicorn and other tools. Yuri Selvanov, the creator of UVLoop. And this guy is actually the creator or like the implementer or whatever of the async and await keywords in Python. And Stefan Benel, the maintainer of, I'm probably pronouncing it wrong, of Cython. Yes, nailed it. Nice. So cool. I have been showing you a bunch of these pictures for each one of the sections. So this is all about the community. This is all these tools, all these things are built by normal people. And in many cases, it's just mostly during free time. And it's just like trying to help others and trying to put stuff out there for others. So all of these maintainers might actually have hobbies, but they probably are doing some sacrifices and some stuff to keep these projects alive. But you can actually help. So you could, for example, for FastAPI, you could help translating a page in the documentation. You can review translations from others. You could answer questions from others. You could help with bugs and features, or you could help with all of these other projects. There's always stuff that can be done to help with these projects. So if you want to help, that will be awesome. And yeah, well, that's the end of it. Thank you very much. I don't know if we have time for questions or thank you.
Basically, is it possible to add some additional automation like commands or anything so it will go into the documentation of a FastAPI as you showed in the code?
Yeah, so the question is if it is possible to add commands or more documentation to the FastAPI documentation. Yes. For example, when you declare the docstring inside of that function, that docstring will be shown in that interactive documentation and will be rendered with Markdown. So you can use Markdown inside of the docstring and it will just automatically show up. Yes?
Sebastian, so after SQL model, do you have any big problems you see yourself solving? As FastAPI, huge SQL model, I think it's huge. What's next? We had this discussion with my colleague and I said maybe Django admin replacement, but colleague said Django admin is anti-pattern. Sebastian won't try to solve this. So,
oh shit, high stakes. Actually, that's a very good point. I want to build something like Django admin. I don't want to make it necessarily restricted to the specific ORM. I have been wanting to build a sort of admin interface that is based on OpenAPI. so that it can read whatever is the information that you are asking for. So for example, if you say like, I want to upload an image, and then I'm gonna return a prediction using machine learning of the object detected in the image, then that would not be automatically creatable, at least based just on the data from the database. But if it's based on OpenAPI, we can use the same data shapes that are declared there to generate that. I would like to build that. That's one of the things that I want to work on. I also want to work a bit on automatically generated clients for Python. There are great clients for TypeScript, for example. So you can get, for the front-end teams, they can get, from the same API that you build, they can get an automatic code that has all the type annotations, autocompletion, type checks in the front-end code based on the back-end code that you wrote. So they can see the errors that they are going to make before even talking to the back-end. I want to improve that a little bit on the Python area. Yeah, I think those are like the main things that I think right now.
I have a question. Yep. The docs of FastAPI, how hard is to protect it? For example, I don't want to expose my documentation, and how hard is this protect that?
So the documentation, like the interactive docs interface, you can disable it just by setting
I
a.
don't want to disable. I want to have it, but I don't want to expose it publicly.
So there are many ways to protect and to like do authentication and authorization and all that stuff, and that will depend heavily on each application. So FastAPI provides the ways for you to use the same tools that generate the documentation and add the authentication that you need. FastAPI has tools for doing authentication also based on OAuth 2, so that you can do things like what I don't know, Google or Facebook do, that you have some permissions, some specific permissions for some tokens and all that stuff. So you can integrate that and then put the documentation behind something like that. But for example, you could just use just cookies and then show documentation only when the authorization cookie is available. Yep.
So FastAPI is awesome on this, awesome talk. Thank you. So the way you do it right now is basically you define the API, right? You can build the documentation from the OpenAPI spec that you build. You can build the front-end again models and so on and so forth, which is great. What is your opinion in general in doing it a little bit the other way around, defining the OpenAPI spec and then generating Python code from that, and then generating front-end code from that? Like there is, I think Python has data model generator. I've seen people start something similar for FastAPI. What is your opinion on those?
Yeah, so you can actually do exactly data model generator. The thing is, that's actually how OpenAPI was made. OpenAPI is the evolution of Swagger, was the first sort of a specification, and it was intended so that you will build first what is the declaration of how the API should look, and then implement the code. But that's a long trip, a lot of work that has to be replicated. And what I have been trying to do is to reduce the amount of duplication of code and information and all that stuff. And at least for me, it's easier to work with Python and with autocompletion. I really love autocompletion, as you have seen. With autocompletion, with inline error checks in the editor and all that stuff. So for me, it's easier to just actually build the API with Pydantic and with at least the shape of it in Python, and then generate from that the OpenAPI, than doing it the other way around. But it's certainly possible. So there are tools for doing it. So for example, if you already have an OpenAPI application, you can also generate, for example, all the JSON schemas for all the Pydantic models, and then, or even generate the actual rest of the application, and then you can just fine tune it. Yep.
Yes, I was always under the impression that when you declare type hints to Python variables, then they don't have any actual runtime behavior. But seeing how API works, it seems that it kind of does conversion based on those type hints, and I was wondering how is that possible?
That's a very nice question. So yeah, these type annotations were not created originally for doing anything at runtime, but it's just possible in Python. So then Pydantic does that to extract all this, to produce that extra capabilities. And in fact, because Python was expecting to just use these type annotations for helping with editors and all that stuff, it was like the main use case. But like even recently, there was some issue with something that could change a little bit the way that Pydantic behaved. But the Python community and the Steering Council, they saw that this is a very important use case for Pydantic, so they actually reverted that because we took a long time to actually complain, so that was bad on our side. But then they actually reverted back so that we can keep using these patterns that can help a lot. So actually, yes, you can use those type annotations underneath. It has a bunch of tricks that has to be done, but Pydantic and FastAPI take care of that. So yeah, you can just use them. Does that answer the question?
Well, it doesn't tell me how can I myself use
Oh.
annotations at runtime.
Yeah, so there are some tools internally from Python itself. So you can use, I think it's in typing, you can just get type hints. Then in introspect, I think is the name of the model, you can extract the information from the function to get the signature of the function to get the parameters and all the stuff. So there are several tools that have been in a couple of different places. I think probably the easiest that you can do to replicate that type of behavior will be to check out the code at Pydantic, or Typer is probably simpler to see because it's not as sophisticated as Pydantic. Also because Pydantic has been doing a lot of stuff to be able to be compatible with different versions of Python that have changed a little bit of those, how these types work underneath, because these types have been evolving recently. So like they are sort of new. They have like, I don't know, a couple of years, well, 4 years or something. So there's a lot of tricks that are done inside of Pydantic to be able to allow that. But probably the best way to actually figure out what are all the little tricks will be to check out the source code for Pydantic or for Typer.
Thank you.
Yep. Yeah.
Follow up on this topic. So the conflict between the uses of types in Pydantic and similar types and what Python wanted to move forward was to make that system more widely applicable, to make easier to annotate different use cases. So how is the progress going on a compromise that improves both those uses and still allows Pydantic, FastAPI, and others to work?
So, for example, with this recent this situation with Pydantic and the new way that type annotations would have worked if they hadn't reverted that, they made the smartest decision, which was to hold back, not set anything in stone, so that it's possible to figure out what is the best way to make it all work with FastAPI, Pydantic, and all this community, and at the same time still benefit all the other communities that just want the type annotations and all the stuff. But yeah, like it's just something that has been going on, and like all the actual geniuses that are building Python itself are checking out like what is the best way to do this here and there, and like how to improve all that so that the evolution can continue to go. But clearly FastAPI and Pydantic have been taking some traction, and the Steering Council knows that there's people that want to keep using those tools, so they are very aware that this is a valid use case, and that they just have to make sure that this also keeps working. And like they made a huge commitment by just reverting something that was already accepted for Python 3.10 to postpone it to Python 3.11. So yeah, does that answer the question? More or less?
Only partially.
Yeah, well, like it's something that is going on, it's in progress. It's not something that is defined or written in stone yet. Yeah.
Sebastian, so I really like that you showed the pictures of open source developers that you base your work on. So I wanted to inquire in specific examples, like let's take Samuel Colvin, Mike Bayer, and Tom Christie. How do you partner with them in real life? Are you friends on Facebook? Do you discuss roadmap? And who of those three influenced you most as a developer or open source maintainer?
It's very fun, like, you know, like we became GitHub friends. So it's just like a bunch of issues, and I ended up just asking stuff, and I don't know. Some of the people could have been annoyed at the beginning because I didn't even know what I was asking about, and some others were super nice despite that I didn't know what I was talking about. But it's just like actually through these contributions in GitHub, and recently that FastAPI has been growing and all the stuff, then I have been talking to Samuel Colvin and to Tom Christie, but I actually have never met them in real life yet, just like, video call and stuff like that. But it's actually quite fun because, like I feel sort of friends with them and with a bunch of other people that I have actually never met in real life, so yeah, it's fun. I think the question about like what is the future of admin with FastAPI, I think that's very interesting, and that shows like what are the missing pieces. I think that's a very good one.
Okay, so sorry for this one or for a book.
So what do you prefer?
He said that a Raspberry Kit.
Okay,
Take the mic.
perfect.
And the book, what? I'll leave it to you.
The book. There were many good questions. There were very good questions. Like I'm actually not sure. This is not a fair way to do this.
He really wants it,
He really wants the book. Who else wants the book? No, actually, let's do something. Who tells me that is not Christian? Who is the author, if you remember, of Ubilove, the stuff that also the author of Async and Await? Yuri, that's correct. Who said Yuri? Just say Yuri. Okay, you got it.
Thanks.
Thank you.